In September 2002, astronomers found an asteroid in a strange orbit around Earth. This surprised them because they only knew of the Moon as a natural object orbiting Earth, so they thought this object must be man-made. It turned out to be the third stage of the Saturn V rocket, which launched the Apollo 12 astronauts to the Moon in 1969. After leaving Earth, the rocket went on an unknown journey for 30 years before returning. But how did this happen? The Saturn V rocket had 3 stages. The first stage burned for about 2.5 minutes, reaching 61 kilometers high. The second stage burned for 6 minutes, sending the rocket higher and faster. The third and final stage did a short burn to put the spacecraft into orbit. Once the third stage was in a stable orbit, it would be fired again to send the rocket and crew on a path to the Moon. After the Apollo crew was safely on their way, the third stage would separate, and NASA would try to get rid of it. On earlier Apollo missions, the goal was to place it into an orbit around the Sun, where it would stay for thousands of years. To do this, NASA aimed to meet the Moon on its far side, where the Moon's gravity would push the rocket into a solar orbit. This kind of orbit was useful for NASA because it kept the object out of the way of future missions. But things didn't go as planned for Apollo 12. To get rid of Apollo 12's third stage, NASA had to send it on a path to meet the Moon. But the initial path was taking it toward the wrong side of the Moon, so the third stage needed to adjust its course. To do this, it used its auxiliary propulsion systems, which were 2 sets of thrusters at the bottom of the stage. These thrusters controlled its movement during flight. Although the third stage had to change its path by thousands of kilometers, it didn't use much energy because making the change early in the journey would have a big effect when it reached the Moon. When the third stage separated, it was traveling at about 20,000 kilometers per hour. To adjust its path, it had to slow down by about 140 kilometers per hour. This slowed its approach to the Moon and made it arrive on the opposite side. NASA thought the maneuver was successful, but it didn't go exactly as planned. The entire Saturn V rocket was controlled by the instrument unit above the third stage, which had its own internal guidance system to plot the rocket's path. The rocket had 2 C-band transponders to send signals back to Earth, helping NASA get more accurate trajectory data. Once the rocket was in orbit, NASA could compare this data with the rocket's own data to check if it was on the right path. If anything was wrong, they could send a command to fix it. However, NASA didn't realize that the tracking system was slightly off, which made them think the rocket was moving faster than it actually was. To reach the target speed, they slowed it down too much, overcorrecting by 40 kilometers an hour. This caused a major delay in its trip to the Moon, making it miss by thousands of kilometers. Instead of being sent into a solar orbit, the third stage ended up in a highly elliptical orbit around Earth. Over the next 15 months, the orbit was stretched and pulled by Earth's and the Moon's gravity. It eventually stretched out to Lagrange point 1, where Earth's and the Sun's gravitational forces balance each other out. Once the third stage passed this point, the Sun's gravity started to take over. It's like a car trying to reach the top of a steep hill. If it doesn't have enough speed, gravity pulls it back down. If it has enough speed, it can move past the top and get pulled down by the other side. This is what happened to the third stage. It passed the L1 point and was pulled into an orbit around the Sun. It had achieved its goal, but this orbit wasn't stable. Instead of moving outside Earth's orbit, it was slowed down and moved inside Earth's orbit. Because of this, the third stage completed its orbit around the Sun a little faster than Earth. This meant it was slowly moving away from Earth, but eventually it would catch up again. This happened in 1986, but it wasn't close enough to the L1 point to be pulled into Earth's orbit. The third stage continued to orbit the Sun for another 16 years. In 2002, it reached its furthest point, just as Earth came into position. This time, the third stage passed beyond Earth's L1 point, and for the first time in 32 years, Earth's pull on it was stronger than the Sun's. Over 2 months, Earth slowly pulled the third stage into a very elliptical orbit around the Earth, similar to its previous orbit. At this point, though, astronomers still didn't know what the object was. To figure it out, they used a method called spectroscopy to analyze what the object was made of. Different materials reflect light in different ways, and the amount of light reflected varies at different wavelengths. So, astronomers measured the light from the third stage at many wavelengths, creating a spectroscopy graph. By comparing it with other graphs, they found it matched the signature of white titanium oxide paint, the same paint used on the Saturn V rocket. Astronomers also traced the object's path and discovered it had left Earth's orbit in 1971. With all this information, they were sure that this was the third stage from Apollo 12. Astronomers kept watching its orbit, and after 1 year, it was again sent into an orbit around the Sun. Their calculations showed that it will return to Earth in the mid-40s. This object will keep traveling through space for many more years, but the laws of physics will always bring it back to Earth every now and then.